Welcome to a tutorial video on Twine 2.1. In this video I'm going to go over some of the ways you can combine various programming techniques that are new in Harlowe 2.0 to create a moving through dungeons technique. And I'll show you what that looks like right here. So one of the most common requests I get is to demonstrate how to move something through an index space. For example, we have the P as a player, similar to a roguelike, and we can move right. Again, notice the space, we can move down, down, left, up. And we can replicate the features here within a roguelike using the new functionality that's part of Harlowe 2.0, brand new functionality here. So I can show you this, like I said, clicking up and left and right and down, and we can move the little P around this little grid here, replicating in a very small way sort of a roguelike functionality of move around a map. However, to create this, it requires a number of different programming techniques as part of Harlowe 2.0 and Twine 2.1. So let's look at this for a second here. So very first in the start passage, we have a named hook, in this case map, or a name tag for the hook map. We're using the display macro to display the passage map. Now I'm not going to look at that right away because I'm going to step through this passage by passage. So the very next thing we have is the start of an alignment, and then another alignment, a third, another, and then we're finally closing the alignment. This is part of Harlowe and how you can align things vertically across the page. Remember, we had up, left, right, and down, and these are the three links using the alignment that's going on here. We're also using the link repeat macro here for up, left, right, and down, so you can keep clicking on it and it won't disappear each time, and it'll sort of remain there. You can repeat clicking on it, link repeat macro. Within each of these, we're doing sort of a similar steps each time. We're setting a variable to the value of the current position of X, and then we're checking to see, in the case of up, if we can move up. Now in this case, our grid actually starts at 0, 0 on the far upper left and goes down to NN, the farthest we can go, on our down and right. And so, in order to check if we can move up, we check position -1. That is our current position Y -1 to see if we can move upwards. We're also using part of a new functionality that's variable in Harlowe 2.0, and that is a temporary variable. It starts with an underscore. Normally variable starts with a $sign, and notice we're using dungeon here. However, row here, and we're going to repeat row all throughout this passage, is a temporary variable. It means it only exists within this passage. And as soon as the passage is done, the temporary variable goes away. This is a way to create the effect of doing the normal global variables and then having a more scoped effect of having temporary local variables to a passage. I'm combining these across the story here to achieve a couple of different effects. The very first thing we're doing is finding the current position of the setting row to dungeon's X position. So wherever we are, position X, find that within the dungeon map, and it'll make more sense when we go look at the map here in a moment. So find that row, double check to see if we can actually move up, to see if Y is not 1, and it'll make more sense when we look at the map. If it is, change position, move us up -1, then replace the map. This is the map up here, name tag for the hook, and run display map again, just like we did up here. So for each step here, up, left, right, and down, we're checking, can we move in that direction given our current position X and our current position Y? If we can, set it, either Y or X depending on the movement, and then replace the map each time. So we're moving if we can, and then redrawing the map. And then checking if we can move, then redrawing the map. Then redrawing the map, then redrawing the map. For each link repeat, up, left, right, and down. Checking, like I said, from 0, 0 to N. So if it's Y, we're moving up, so that's a negative. If it's left, it's a negative. If it's right, it's positive. And if it's down, it's positive. So NN, bottom right, 0, 0, upper left. So we're moving through each of these, up, left, right, and down. Let's go look at the map here for a second. Now I'm using the startup tag on our startup passage, and it's convenient, at least for me, to name them the same so I know what's going on. And we're setting a couple different initial variable values. The very first thing we're doing is setting an array of arrays. So here we have the dungeon array set to a number of different arrays. Each array here within the array, the inner arrays, is a row in our map. So we have our first row, our second row, our third row, fourth, and fifth. Now, if you want to take this code and extend it, something you need to keep in mind, in the way I've done here, is that the grid needs to be the same number. The X and Y have to be the same number for this code to work perfectly. You can play with it a little bit if you want to change the code for irregular sized dungeons here, or maps, but it works best if it's the same number, so our rows and columns here are the same. So this is our first row, our second row, our third row, our fourth, like I said, and then fifth. Now, if you remember, and I'll go back to this and start, for left, we were currently checking the X position. So we were going through dungeons, positions, indexes, finding that row, then checking in rows X position, position X minus 1, if we could move in that spot. So if it wasn't 1, we can move. So the zeros are our movement and the ones are our walls here. Now we're also initially setting a position X to be 2 and position Y to be 2. And we saw that, if I refresh here, that it started up here in this corner, which is 2, 2. Which is right here. And we can change these if we want, as long as we put them here within the zeros. Because remember, we can't move through ones, those are our walls. So in this case, using the startup tag on a startup passage, I set the initial dungeon array to a set of arrays. I set initial position X to 2, and set initial position Y to 2. So it allows us to set everything up for our map using the startup tag on the startup passage. And then we immediately move into the start passage, which is aptly named because it was the beginning. So we see the all different link repeats. We can check up, left, right, and down. Now finally we move to the map passage, which is called through each link repeat macro within the start passage. And it's where some of the most complex code is going on within this story. So let's open this up and look. Now it's fairly long, but I've put comments in here using HTML comments so that everybody can go back and review, and so I can review as well, so what exactly is going on. So the very first thing we're doing is we're actually going to build an HTML table, and this will allow us to use different font sizes and still have the same spacing. It's not exactly ideal, but it will work for what we're doing here. So the very first thing we're doing is we're beginning resetting, if it's the second time, the first time we're creating dungeon table to be the open table element, and then we're setting an I to be 0. Now in this case, and in the functionality I will go over in just a minute, we need I's and J's to keep track of our rows and columns as we're moving through the array. Now the reason we need to do that is because the for macro, which is brand new within Harlowe 2.0, does not keep track of the index, as it allows us to iterate, that is, move across some type of data, in this case an array, or an array of arrays actually. But it doesn't keep track of the index, which is why we need an I, and we need a J. So we start initially setting I back to 0, so reset it. Then we're combining a number of different functionality that's brand new in Harlowe 2.0. That is, first, the for macro, which allows us to for loop through something, combined with the each keyword, which is to say, for each item within whatever we're going through, set it to some new variable. In this case, we're using row again, and we can use row again because in this case, for this for loop, which is considerably long here, a row is temporary. So for each entry, so for each row within our array, and we're using this functionality as part of Harlowe, saying the entire array. So for each entry within dungeon, set it to row each time. And so we can iterate, that is, move through the inner arrays of our larger array structure. As we do that, we also need to keep track of its index, that is where we are. So we start at 0, and then each time we move through this loop, we're going to increase I by 1. So set I to it plus 1. And then to create a new row for our table, we use the tr element, that is table row element. So we add the strings together, that is concatenating them. So we start with table, then we begin a row, then we reset our j because we're about to move into column space. So for each row and then for each column. So now we're going inside the larger array as part of this inner array. So for each inner array entry of our larger array. And we're using the same setup here. So for each column of row. Now let me show you what that looks like as we move back to startup here. So our very first time, we're moving to the first row, so this first array, and then we're moving value by value across this. So column, in order, will be set to 1, then 1, then 1, then 1, then 1. And then we'll move to the next one, and column will be set to each of these in turn. So we reset j each time we move to a new row, so it's always equal to 0 as we go through the columns, and then we move through the columns. And just like we increased I, we increased j each time. And then we do a number of different tests, which allows us to draw the map using different things here. The very first thing we're going to test is if position y and position x are equal to I and j in turn. If they are, we add a p. So we add table data td with a p inside the row we created with the tr. So table, we open a row, and then we set a table data td with a p here. So we're building the table as we move through these different loops. We need to check, of course, to see if y and j are equal to position y and position x. Now this may seem confusing that they seemingly are inverted. The reason of that is that we're moving through each row and then moving through each column. So we're not moving x, y exactly, we're moving the other way as we iterate through these. If these are not equal, then the very next thing we do is see if this is an empty space. Now I purposely phrase this way, if and then else, because this allows us to put extra things in here. If we wanted to put in treasure chests or enemies or anything else, we first check to see if it's a player. If it's not a player, then we do all our other things. So in this case, we just place a dot for the zeros, and so that shows us our empty space, as we saw right here, the periods for the empty space. But we could also put extra things in this block right here. Finally, we set in the walls. So we test for ones. So if column is equal to 1, then we go ahead and add a td, table data, and a hash, and that lets us build our walls, as we saw, around the edges. So finally, we close out the table row, because we're building this row by row by row, with /tr, and that closes the table row within the table. Once all of the loops have run, all the way through the rows, all the way through the columns, then we finally close off table data by concatenating the close tag for the element table. So we've built our entire table now. And then the last thing we do is we get Twine to show the value. And we update the HTML table each time. So each time map is run, it goes through the rows, goes through the columns, checks to see where the player position is, position X and position Y, and then places the empty spaces as periods and hashes as the walls, and then finally prints the new table. Then as we saw back here in the start passage, it is initially run once as part of the initial display, and then for each link repeat it's replaced and replaced and replaced, and so each time one of the links is clicked, it redraws the table, as we saw. It's not particularly fast because it's doing a lot of different things here. Something to keep in mind as well. And notice that we can't go right, because that's a hash, but we can move in other directions. And it allows us to do it because the code is checked each time. And so as you can see here, using new functionality that's part of Harlowe 2.0, we can use temporary variables. That's those that start with the underscore. We can also use the for macro to iterate through something to move item by item by item. We can also use the each keyword for each to move through things that way. We can also use the existing functionality of the three dots to mean an entire data structure, in this case the entire dungeon array, and we can combine for loops, two of them in this case, to first go through each row of an array of arrays and then go through each value within those inner arrays. We can use that finally to build an HTML table, and so we can get this effect, so where everything is equally spaced. We can also combine that using the link repeat macro to repeatedly click on links, our left, right, down, or up, left, right, and down, that is, to in each case replace our map and redraw it and redraw it and redrawing. And we combine a number of different things, and particularly within Harlowe 2.0, temporary variables and the use of the looping to rebuild our map each time. And finally, which hasn't been possible until now, to build maps that work this way, or build dungeons, that is, that work this way. So as you can see, we can combine these different functionalities in a complex manner to build a sort of roguelike, very simply roguelike way of moving through these maps. Thanks for watching.